Welcome to EDU World Space.
This question is going to go ahead and take a look at density. And we want to remember that density is a measure of um, mass over volume for a given substance, and usually measured in units of grams per milliliter. So there's a few different parts to this question. The first tells us that our sample has a mass of 38.5 grams and the volume is 45 milliliters. Well, those are going to be units that we can easily utilize for density here. And so in dividing this out, so when we do the division here, we know we're going to end up with a number less than 1, but use our calculator and round it to two significant figures, we end up getting a volume, or a density rather, of 0.86 grams per milliliter. So that tells me that between toluene, whose density was about 0.87 grams per milliliter, versus the isopropyl alcohol, which was about about 0.79 grams per milliliter. Um, the density clearly matches the toluene's density better, and therefore toluene is the likely identity of this substance. So the second part of the question says that we have a 45 gram sample of ethylene glycol, and they give us the density here. So what I tell students to do when they approach a math problem like this is start with what they give you. They give you that the mass of the sample is 45 grams, and we ultimately want to find out what volume of ethylene glycol that's equivalent to. So dimensional analysis is kind of the easiest process to use here. Take the density that was provided, the 1.114 grams per milliliter, that's for the ethylene glycol sample, and just place it in a format in which your volume, the thing you want to know, is on top and your known mass is on the bottom. And so essentially, you're going to end up taking 45 grams and dividing it by the density provided here. And you're going to end up getting about 40.4 or so milliliters as you work that out. And just notice here that we're only allowed to keep two significant figures. So the best answer here would be 40, keeping just the second significant figure there, 40 milliliters of ethylene glycol will be used then to represent the 45 gram mass sample that will be measured out. Now you want to use a sample here or a graduated cylinder that allows you to measure the volume. Now, in a question like this, if you're wanting to get the proper accuracy so that you could be sure that the volume is measured out to the nearest unit in this case, so to the ones place, you'd want to have a graduated cylinder here that would measure at least um, to the tens in terms of the volume. So, for example, here, if we want to be assured that we have 40 milliliters measured out, we want to use a graduated cylinder that measures or has lines that indicate at least to the tens place, so that an estimate of a volume that falls, say, in between these lines, we could estimate with an additional significant figure, and that additional significant figure would figure into the ones place if the graduated cylinder had measurements to at least the tens in terms of the volume. So any graduated cylinder measured out to the nearest 10 milliliters or more accurate than that would be perfectly sufficient for making a measurement of a volume with in which you need to know accuracy to the nearest unit, or to the ones place in this case. The final question just addresses utilizing again density to help us determine the mass of a known metal sample. And it starts by giving us the density of nickel. 8.90 grams per cubic centimeter, and a cube of nickel, which is 5 centimeters all around. So let's start by determining the volume of the nickel, which we know is length times width times height. Each of those numbers tells us, because it's a cube, is the same. Each is 5 centimeters, so we're going to multiply 5 times 5 times 5 and get an answer of 125 cubic centimeters for the volume of this cube of nickel. So that we can keep that, by the way, to 3 significant figures because that's what each of the measurements has. Now let's take that number and again utilize what we know, 125 cubic centimeters, and utilize or sort of manipulate the density here so that we have mass on top where we want it, 8.90 grams, and cubic centimeters, the volume units on the bottom. We can cancel these out, and as we do the math here, we end up getting 1125 grams. Sorry, I knew something was wrong there. It should be a 1112.5 grams. All right, but notice we have 3 significant figures in each of these measurements, so we're going to need to round this to 3 significant figures, or to the first 3 places here. So 2 is going to round or keep the 1 value as it is, and so a more exact or precise answer to this question would be replacing that 2 value, just having it be a carrier digit. These 3 are my 3 significant figures, 1,110 grams of nickel being used in this sample.